Sorry. Next time. इससे अपना
Syria.
How many people there?
So already the guideline has given that 7 minutes is for the presentation, 2 minutes for the discussion, 1 minute for question. Okay.
So let us do it. Okay. What he said, you know, the presentation will take us 7 minutes, 3 minutes to start. So we have completed. Okay. Whoever doesn't matter. The first one will presentation by Sagarika Bhubaneswar. Open air synthesis of two-methylene three compound using copper. Okay. 17 session or 16. But you have to 17. Okay, doesn't matter. Let us start. Sagarika Bhubaneswar.
Good afternoon to all. Myself, Dr. Sagarika Bhubaneswar. Today I am here to represent my research work, which was done under the supervision of Dr. Bhubaneswar in Department of Chemistry, OUTR. Today I am here to represent one of my research work is open air synthesis of 2-methylene 4-chromanols using copper-1 catalyst. So, with the objectives of today's presentations, the importance of chromanols, literature reports on methodology for the synthesis of 2-methylene chromanols, optimization reaction conditions, and interesting outcomes on the preparation of substrate scores, mechanism study, conclusion, and approachment. So before going to details presentation, why you are interested to synthesis these two methylene chromanoids? So we know that the oxygenated or the chromanoids and flavonoids is a huge biological active pharmaceutical drugs, and you can see these are some examples of oxygenated heterocyclic molecules where the benzopyrene systems are incorporated in the central of molecules, so these drug molecules. And due to this wide application of 2-methylene chromanoids, we are interested to synthesis this moiety. So, Peters et al. Also reported on total synthesis of gamma-rubramycins, which is a 5,6 spiroketal 5,6 spiroketal moiety, which is easily synthesized by this retrosynthetic perspective by cycloaddition of orthoquinone methyls and enolic ethers. That means benzo 2-methylene benzopurane or benzopyrene system. So, due to this wide application of these molecules, we are interested to synthesize these molecules in our laboratories. So, these are the literature reports where very little amount of literature reports on the synthesis of 2-methylene chromanoids. These are only 4 reports where the 2-methylene chromanoids, and you can see all these reports, the 2-methylenes are not freely available. Either the one of electron withdrawing group attached to it, or also there are also hydroxy group in the vinylic position. So due to this small scanty of literature reports were prepared our laboratory direct approach by the presence of unsubstituted 2-methylene chromanoid. And here also see it these two are similar reports, like one with alanine ketones, another is alanine esters. So we know that alanine ketone, alanine esters the stability issue. We can't handle in the open air or also in the high temperature. After in room temperature also they can easily degrade it. And another 2 reports by Wu et al. And Roy et al. They are cyclopentadiene like TB type reagent. That also the handling of reagent and storage of reagent also very challenging. So to avoid these the drawbacks of previous reports, we have synthesized these 2-methylene chromanoids by using copper catalyst. This is the first report for the transition metal catalyzed protection group free synthesis of 2-methylene chromanoids. And without any literature reports were tried with different catalysts by using, like we thought that maybe it goes through the alkyne activators. So we tried the reactions with silver chloride, silver nitrate, and FeCl3 and many other copper catalysts. So we conclude that in presence of copper bromide, sodium ethoxide base at 80-degree temperature, it gives a excellent good to excellent yield with open air condition. And another also, no protection group free is required. And this starting material can easily prepared from the salicylaldehyde through barbier granulate using propazyl bromide. So these are the substrate scopes. For generalization of our methodology, we can changing the substrates, changing the substituents on the aromatic rings. We get good to excellent yield, and in presence of dihalide also we got good yield. So and another changing the substituents in the aliphatic chain. That means we are substituting these alkynes with another alkyl groups. And in that case also we got good to excellent yield, and this is also 2 OH are free, and we are no need to protect this free free OH, and these free OH are not affected in the reaction conditions. On the reaction period, these are free. So during this preparation of these substrates, where we get another observations, that hydroxylation of alkynes. We know that this is the racemic mixture. In barbier granulate, this is the racemic mixture. So by addition of n-butyl lithium, that may be generation of 2 diastromers. But in this case, we got only 1 diastromers, and this 1 diastromers, and these diastromers also changes. Means these diastromers again further substituted by phenylcyanobromide, again we can get by crystallographic study we got that these OH are syn position. That means there is a relatively cis. We're not going to there's a trans product, or maybe this is the upside or downside. We got both the OH are in the syn side, means there's a cis relatively stereochemistry got. So we observed that it maybe goes through the Bouguer-Dunizzi trajectory. That means the lithiated ions coordinated to the phenoxide ion, and this incoming electrophile, LUMO and LUMO Pasteur and HOMO of alkynyl carbon ion generates a perfect Bouguer arrangement. That means this ion gives only one type of attacks. That means due to this the maximum overlap occurs in one side. That's why it generates only one stereoisomer, relatively one stereoisomer rather than the other. So this study also confirmed by the crystallography structures. In both the cases, these OH are in the same sites. In cyclation also, these OH are in the similar sites. So by mechanism study, we changed the substrate, we thought that it maybe goes through the other, why it doesn't go in the cesium carbonate, but in cesium carbonate in thought endo product rather than the exo product. That means these double bond go inside. This means 2-methyl chromone. So why it happened? Because of this in copper chromate. There is also another report we got found that in presence of copper chromate and cesium carbonate, it forms a bridged catalyst which first oxidize this benzylic OH. So due to oxidate this benzylic OH and this phenoxide attached to the this alkynyl carbon and generates this 2-methylene chromone, which on isomerization generates 2-methyl chromone. So and also we change the substrates from the propazolic to allylic. In that case, we are not getting the cyclized product. Rather, we got the dehydrogenated product. In presence of base, you can see that in presence of base, it generates this dehydrogenated product rather than the cyclized product. So we thought that, so we conclude that the reaction goes through the alkyne activator and goes to this alanine intermediate. We show that first in literature report there are some reports this is the alanine esters alanine ketones. But we in our proposed reaction we have generated in situ alanine cation so that the reaction goes through it. But rather we are in align alcohol, this reaction doesn't go. So the stability of this propyl alcohol is more than 3 years. We can store in our lab also in normal room temperature or refrigerator also you can store. So easily also you can column purified. But in alanine esters, column purification is very difficult. So this is the reaction mechanism. The phenoxide is the 6-exotic cyclation by phenoxy assisted in penicillin solvent case generates these 2-methylene chromoles. So after the synthesis with optimized or we try to modify the substrate or change the desired product to the different molecules, whether it will be goes through the conclusion means this here after the hydrogenation we got different type of molecules, so we can thought that a 2-methylene chromone can act as the building blocks in the many organic transformations. So, the conclusion where this is the methodology for synthesis of 2-methylene chromonols, and also it highlights the generation of syn-3 hexane diols by the Bouguer-Dunizzi trajectories. And this is the announcement. Thanks to my supervisor Bhubaneswar sir for the supporting and UGC for fellowship and NIT for labs, and lastly not the OCS and the OUTR for the presenting my work here. Thank you.
Good presentation. One question is mine that you have done some literature study, okay?
Yes, sir.
Can you why you have taken copper one at least? Why not other?
Actually, we're
What basis do you think that the copper one at least is?
Copper one it are alkyne activators.
But is the only copper one is there or any other material?
Gold also is there, but instead of gold, another reports of my republic is gold, which is used for the alkyne activations.
You have done.
I have done in gold catalyst, but if it reaction going through the copper, so we can go after the gold. Gold also going with.
So what you do after the reaction is over about the catalyst? So every time the catalyst is lost.
Actually, we're not reuse that because we're using 5 mole percentage of
That's my question,
catalyst.
that whether it can be used or every time you have to use this
I'm not,
catalyst.
we're not reused that one.
You have not done.
I have
You
not done.
Thought of.
The silver plate, even silver plate, or it get used.
Actually, these reactions we get only sluggish type reactions. I mean, we are not getting any product. A little bit. There's no reaction happens. But we're in reaction condition. We're using only 5 mole percent, and in optimization condition, we're using only 5 milligram reaction scale. We're not starting matter in 5 milligram scale. That means in 5 milligram scale, the 5 mole percent. That is very like.
Whether any milligrams you take, mole percentage anyway 5 mole percentage.
Yes.
Whether you take 100 milligrams or 200 milligrams.
Yeah.
Mole percentage is
I
same.
mean,
Huh.
won't not mean that it is already milligram level. So
No, no.
Anyway, that's not.
even it goes to the environment,
So this
it
one-
became level.
My question is this what you have done?
Yes.
You have done yourself?
Yes. Yes.
In laboratory?
Yes. Yes.
Published in 2020.
Yes.
So you completed your PhD.
Yes.
That means you have already got award on this basis. So why do you present again for this? Is it not a duplicate? Duplicate means this work you have already been awarded with PhD degree on this basis.
Actually,
You have already done
हाँ,
anything new you are presenting here?
not
After
means in
PhD,
defense after
like-
PhD I am not.
some extension work maybe.
हाँ,
Like have you done?
the hydrogenation that one means that hydrogenation for I thought that no, that is total synthesis. We can use that 2-methylene promone. So we are trying the hydrogenated that for last slide I shown you that we hydrogenated these molecules with different.
Okay. Thank you.
Next,
Get ready.
1919. Suppose
So, good evening to all esteemed delegates present over here. This is Subhashi Mahapatra stand for you to present one of my PhD research work on focused upon one-step electrodeposition mediated synthesis of mixed metal sulfides for hybrid supercapacitor application. So, these are the contents of my presentation. To starting with some background study, if we say to resolve the energy crisis that we are facing now, several research efforts have been developed to develop several energy storage technologies like rechargeable batteries, supercapacitors, fuel cells, electrolytic capacitors, and flow batteries. Now, to evaluate the performance of the devices, there are two basic parameters, that is energy density, that means how much the energy can be held by the device, and second parameter is the power density, that is how fast the power can be delivered by the device. So right hand side we can see the plot that shows the performance of various devices, that is called as a Raygun plot. So here we can see the hybrid supercapacitor is dominating, where we can it is showing higher power density compared to other devices, and it is also showing comparable energy density in response to the rechargeable batteries which are used most of the nowadays in laptops or mobiles. So in focus of that, we are focusing upon developing electrode materials for hybrid supercapacitor. So what is a hybrid supercapacitor? It is basically a combination of a battery electrode which shows a Faraday-like reactions and a capacitor electrode that shows a non-Faraday like reaction. So what is the benefit of that? The benefit of that, it will help in increasing the potential window of the device. Second, it will provide the basic of better stability. And third is that it will enhance the energy and power density of the device. So basically, in our hand, we have three parameters where we can regulate the performance of such devices. The first parameter is the method. Now, since there several methods have been developed till now to develop the electromaterials for the devices, we are focusing upon electrodeposition method. What is the unique of that? So, in electrodeposition method, it involves the direct deposition of the materials on the conductive substrate that we are taking without involving any binding agents. Like in other conventional method, we use like a binding agent or conductive substrate for the during the electrofabrication, but in this method it is not used. So that is why it is said as a binderless technique. Then second parameter where we are focusing upon the electrode material. Now there are some materials that has been used for the industrial devices like metal oxides or we can say carbon-based material. Here we are using focusing upon transition metal chalcogenates, which is also been used, but it is in an early stage, which includes a family of smells like metal sulfides or selenites. Then they show promising properties like high electrical conductivity, they show high rich Faraday reactions and superior redox activity. And the third parameter we are focusing upon the electrolyte. Now there are several electrolyte being used like aqueous electrolyte, organic electrolyte, ionic liquid, solid polymer electrolyte, and gel polymer electrolyte. In this one we are using aqueous electrolyte because it's easily available. They are non-flammable, they are not toxic in nature, and they show low resistance and high ionic conductivity for the electrochemical performance. So, basically considering those facts, we are in this work we are focused upon we are synthesizing of mixed metal sulfide through electrodeposition method where we are altering the deposition mode. So there are two deposition mode we are using. That is first is the chromoamperometry mode, that is denoted as CA mode, and another one is cyclic voltammetry mode. So in here I have taken cobalt nitrate, nickel nitrate, and copper nitrate in an optimized ratio as the precursor one with a thiourea, and we try to deposit it on the nickel foam that is taken as the conductive substrate, and we have varied the mode of deposition. First one we did in the chronoamperometry mode where we have given a constant voltage for 5 minutes, that is at minus 1.2 volt we have given for 5 minutes, and we deposited it in the nickel foam. And the second deposition mode we use is the cyclic voltammetry where we have given a potential range of minus 1.2 to 0.2 for 10 cycles. And the mechanism we understand what is occurring. Basically, this is the working electrode, that is the nickel foam. This is the reference electrode and the counter electrode. So, under the application of the electric field, the ions, that is the metal ions that are present, they move towards the nickel foam and they try to deposit. On the nickel foam by undergoing the anion transfer reaction between the cobalt nickel copper as the metal ion and the sulfur ion as the anion source. So after depositing on the substrate, we did a physiochemical titration, basic physical chemical titration like XRD, where we confirm the mixed phase formation constituting CO9SH phase, NiH2 and CO2S phase in both the mode of deposition. Then the second one is the same image of the CV mode where we saw the non-uniform nanosecond morphology was obtained with very small pores. Whereas in chronoamperometry mode, we got a very highly interconnected nanosecond morphology resembling like a nano honeycomb-like structure. And this, when we carried out the same study of this sample, that we got a highly interconnected translucent nanosecond-like structure, which we expect that it would help in the electrolyte transportation that improve the electrochemical performance. And this is the space analysis of the CA mode deposited sample where we got the presence of cobalt, nickel, copper, iron, copper and sulfur in multiple oxidation states like cobalt plus 2, cobalt plus 3, nickel plus 2 and copper plus 2. So after confirming the mixed phase formation in both the mode of deposition, we did the electrochemical study of the sample. The first one is the CV plot where we see that the CM mode, that is the blue line, CM mode deposition is showing the highest redox current compared to the CV mode of deposition, which is well confirmed from the GCD plot also, where we can see the discharge time was highest for the CM mode compared to the CV mode of deposition. And then we calculate the specific capacity of this electrode at various current density. We can say the CM mode, that is the chronoamperometry mode deposition, show the highest specific capacity compared to the cyclic voltammetry mode. We have calculated that this CM mode showed a specific capacity of 460.15 coulomb per gram at a particular current density of 1, and whereas the CV mode showed a current density specific capacity of 154.02 coulomb per gram. Then, considering the CMO deposition as the optimized electrode, we did a CV study at different standards where we can see there distinguished oxidation peak, oxidation and reduction peak, which shows the battery type behavior of the electrode material. Now, to confirm this battery type behavior, we did a theoretical analysis using the Dune's theoretical model where we have calculated the diffusive and capacitive contribution in this mechanism. It was seen that the diffusive contribution was major compared to the capacitive one, which confirmed the battery time nature of this electrode material. Second note is the we have used the power law equation to determine the value of B, that is slope value. In this logarithmic plot of current and standard, we got a slope value of B is 0.4. That confirms that our material was showing a battery type behavior. So considering this CMO deposition, considering the best electrochemical performance of this mode, we fabricated a hybrid supercapacitor device where we took the CMO deposition electrode as a positive one and the activity carbon as a negative one, and we decided that optimized potential, which is found to be 1.5 volt. The device will show the maximum voltage. Then we calculate the specific capacity of the device that shows which is found to be 275.27 coulomb per gram at 1 ampere per gram current density. For practical application, the cyclic stability is very necessary. So we did a 5,000 cycle of charge discharge with where we can find that the device will show a capacity retention of 95.4% with a coulombic efficiency of 92.2%. And interestingly, we can see enlightened. We could power a orange light LED bulb where we serially connected three hybrid supercapacitor devices. We could power a orange LED bulb. So I conclude my work that we have synthesized mixed metal sulfide in one-step electrode deposition method by altering the deposition mode. And from this two modes, we found that the chronoampered mode was the best one compared to the cyclic voltammetry one. And this will be used for practical applicability where we could devise a good hybrid supercapacitor device for real-time application. And the most advantage of this method is that we did use any binding agent compared to the other conventional method, which is expected to increase the electrochemical performance. So I acknowledge that I am grateful to my guide, Professor Nirmananda Das sir and Dr. Banki Tripathi sir for their continuous guidance and motivation during this work. I am also thankful to ORI for the research fellowship, Department of Chemistry, Uttar University, and IMT for providing the necessary facility. And I'm also this work has been accepted for publication in SCS Applied Energy Materials. And I'm also thankful to the organizing committee for giving me the opportunity to present my work. Thank you.
We're not showing any literature study. Whether people have done it. Previously, anybody has worked on this?
Yes.
Yes, and what is the difference you have done?
Ma'am, mainly work has been done on single and bimetallic sulfide majorly has been done. Ternary metal very rarely has been
Rarely
reported.
means very no literature in your soul.
I have just shown a background studies little bit.
Any presentation here after, anywhere you are going to do, something on at least 5 years presentation you should give. It will be, okay. Second thing, you go to first slide, first or second slide, so started. One, two, second, third, yes. Nowhere you have told me what is your raw material. You have only told that I have made this sulfide system. Nowhere you told what is your raw material you have started. You say only this is the method I have done. All these things calculation have done, but here you have started what materials you have taken.
I think cobalt nated, nickel nated, and copper
You have
nated.
not told me. First time you are telling after 10 minutes. Okay, second thing, perfect. Okay. Do you think that why thioethene? Why not H2S we can take, suppose let us say basic radical mechanism we are doing in class 2 level. The group 2 things we are actually doing in that copper sulfide, cobalt sulfide, nickel sulfide. Why we cannot do it in H2S? Why in thioethene?
And the salt, we are making a homogeneous solution. Means we need a salt. H2S is a gas.
I can make it in gas or anything, water, soluble things. Anything I can take. I want a sulfide ion to be added to copper and nickel electrolytes. Why thiamine?
With the sulfur sodium electrode deposition, we are making a homogeneous solution where the
Fundamental and I know what you are doing. I'm just asking.
we are taking
What is the pH of the conditioner?
nearly 6.
Any reaction, please put the pH of these things. Another thing, find out whether it's just a suggestion. I'm just asking you. Cobalt, nickel, copper sulfide you are taking. Which sulfide you are taking? Okay. Percentage you don't know. What is the percentage of all three?
It is an optimized ratio I have taken 3:3:2.
You have taken. What you got? Very good. You have taken 3:1. Suppose I take 5 grams. I will not take 5 grams of materials. Maybe yield will be 50% or something like that. Right? So we have to find out what the percentage of cobalt sulfide. You have not done, doesn't matter. You are showing only super capacitive things. But you can find it out. Another thing, always mention pH. Because on this pH only, have you heard of the dispersing agent? Have you heard of the, what I can say, PZC, point of zero charge,
Neutral charge.
point of zero charge. But we do always at that particular pH, whatever PZC will be there for that particular cobalt sulfide, there only we filter material. There will be no charge outside. So those are the things, these are the first fundamental things you should know for any reactions. pH reaction, then what is your pH, what is that PZC material, suppose if you want to have cobalt sulfide, what is the PZC of cobalt sulfide? Whether you have already done cobalt sulfide or cobalt HS, maybe I will get some other things. Some other materials also I will get it, not sulfide only. You are thinking that you have got cobalt 9, yes. Okay.
Ma'am,
Yes, please.
suppose we go to your slide, you have mentioned that is specific capacitance by 2 methods. Yes, that is from chronoamperometry.
Thank you. There are two methods here.
So why this two values that is in cyclovoltammetry technique? It is about 1/3 of this chronoamperometry.
It was due to the morphology. Means, if you see the morphology and in the CV mode, the morphology was not very, as we have written, was not in the highly on the very small pores were there, and it was not the non-uniform nanoscale morphology was there. It was not facilitating the electrolyte movement, or it may be that there's less electrode and electrolyte interfacial interaction. But whereas in CM mode, we've got a highly interconnected morphology, which could facilitate the electrolyte transportation as well as the interaction between the electrolyte and electrode was enhanced.
So this morphology is after the specific capacitance measurement or before?
This is the calculation.
Before specific capacitance measurement.
It is then the calculation. Means I have deposited the electrode, then I took the electrode for the same as
Okay.
The compositions are same. Both
yes, sir.
CDL.
In both the modes, this composition is.
How do you differentiate between a capacitor and supercapacitor?
Supercapacitor, they generally store the charge by either by redox reactions, oxidation or reduction, or they can store the charge by double layer, like negative charge and positive charge. Capacitor are generally electric double layer capacitor, we say. They store the charge like there is one negative layer, there is a positive layer, so there is an electrostatic attraction visible. Whereas in supercapacitor, there are 3 types of mechanism. First is we can say DLC, that is one type of supercapacitor. Second is one pseudo capacitance where the main redox reaction occur. Another is the hybrid one where they are incorporating both.
Ohmic sound.
Sir, 20, sir.
Yes.
Good evening to all.
Come down.
Good evening to all. My name is Amit Sahu from OUTR University, under supervision of A.N. Acharya sir, Professor A.N. Acharya. I am presenting on the topic of synthesis catalysis of lanthanum quantum dot as a new biosensor for carbohydrates and picric acids. These are my contents: introduction, synthesis, characterization, result and discussion, application, conclusion, alignment. Introduction: basically, quantum dots are the nanoparticles which sizes ranges from 2 nanometer to 10 nanometer and have optical properties like photoluminescence, and they are the semiconductive matters which ranges wide semiconductor matters which ranges from maximally 3.7 to up to 6.5 nanometer band gap energy, electron volt band gap energy, and due to their small sizes they are used as a in cytotoxicity or biomedicine, and for a photoelectrode, and for their photoluminescence we can use as a biosensor also. In this case, I using as a biosensor, and futuroscope is my using as a biomedicine or bioimaging. Okay. This is my synthesis process. In first, we make a aqueous solution of lanthanum metal salt, any kind of salt, and a reducing agent, any kind of reducing agent. Then start at a low temperature around 0 degrees Celsius. Any kind of. So I am using, in this case, I am using sodium boride as a reducing agent, and synthesis at 0 degree, around 0 degrees Celsius, and I get a formation of white color lanthanum concentrated materials, and I can separate these quantum dots from the liquid solvent to solid powders through centrifuge and oven dry at 90 degrees Celsius. This is my reaction scheme, lanthanum nitrate balanced reaction scheme. Then characterization. I have characterized through this method as the XPS, then XRD, efficient EDS for purity, HRTM, and photoluminescence and UV. UV for band gap, and photoluminescence for the optical properties like photoluminescence properties. First graph is my XRD pattern for the lanthanum conductor. From this pattern, I got the three kind of mixture of crystal structures. One is the hexagonal, second is the cubic, and another is a hexagonal. But in this crystal JCP number, these are the La4 atoms, and in this La2 atoms. These are the peak results, and these are the confirmation of lattice parameters A, B. Okay. Then second is the XPS. From XPS, I got the lanthanums are state of oxidation state is 0 in this lanthanum quantum dot. Due to these are the metal quantum dots. Second, these graphs are the 3D lanthanum 3D high resolution peaks. We also do the survey for purity, but due to less time, I cannot show. Second is the band gap. Third is the band gap from solid EVG. This is the solid EVG curve, and this is the band direct method band gap curve. From this, I got the two range mixture of nanometers. One is 4.66 electron volt, another is 3.26 electron volt. If we convert this electron volt to nanometer, then this convert to this is nanometer 380.32 nanometer using Beer's number, and 266.06 nanometer. Electron volt को हम यदि convert करेगा तो nanometer को इधर convert हो. First graph is the 266, which is the 4.66 electron volt. From if we take 266 or 265, nearly 265 as excitation energy, then we got two peaks. One is a 1 peak 380.5 nanometer, and if we take the maximum emission energy as a 385.5 nanometer, then we got two excitation energy. One is also nearly to this peak, okay, this energy. And if we take as a first is the we take the 382.5 nanometer as the excitation energy in first graph, and I got the 438.5 nanometer emission. If I take a maximum emission at a 385.5 nanometer, then I got two peaks for excitation. One is 265, another is 382.5. If I excited at 265, then I also can get this emission peak. From this, another is the 266. I excited at 265 nanometer, then get two peaks. One 315 nanometer, another is 440.5 nanometer. If I take the maximum emission as a 4315 nanometer, then I get only 265 nanometer. From this, I can say if I excited at 265, then I can also get 2 for both range quantum dots. Okay. Then after these two graphs are taken in ethanol meter, and second graph is the third graph is the in aqueous meter, at which I excited at 249 nanometer, get 272.9 nanometer, and vice versa. This is the my well distributed quantum dot proofs. I changes the excitation energy from 250 nanometer to 470 nanometer. I got the these are the my wave excitation maximum lambda meso, excitation of shift. The red is the for the 440 nanometer around excitation energy, excitation value, and black is the 315 nanometer. The black is shifted towards blue shift, shows the blue shift due to higher nanometer. That shows the quantum dots, which are 4.66 nanometer. They are well distributed. This is the daylight picture, and this is the under UV light. Shows process, blue process. This is my HRTM image. From this image, this is the 10 nanometer scale, and I got the quantum dots here, which under below 10 nanometer maximally. And from this side, I got the irregular shape of the spherical quantum dots, which size between 2 to 6 nanometer range. And from FKSM also, I can show the nanometer. This is the 100 nanometer range. If I zoom it, then I can see. Yeah, 100 nanometer. Okay. If I zoom it, all are the 100 nanometers. If I zoom it, I can show the particles also up to 2 to 6 nanometer range. This is the my purity EDS spectra, from which I can say this compound only have the lanthanum. This oxygen and carbon for the carbon tape, this and oxygen for the moisture. Application. As I told, I use as a biosensor for carbohydrates and picric acid. I also show the binding properties of the my quantum dots with DNA and RNA. These are the characterization of applications of the quantum dots in changing 0 to this is 0 to 47.14 micromilimolar range of the DNA concentration with lanthanum quantum dot. These are the Sternberger plot, which aspects also shows the well fitted Sternberger plot. Then this is the equilibrium binding equation. This equation is the equilibrium binding equation. From this n number is the number of number of the quantum dots bind with the DNA. From this curve also fitted well 0.973, and the n value I got the 1.65, which is also we call more than one DNA, one quantum dot can bind to DNA. This is for the also RNA, which ranges from 0 to 37.74 millimolar. These are the also Sternberger plot, well fitted and equilibrium plot. But in case of DNA, there is two peaks. One is a 3 in before. Again, so 365 peak also. In case of DNA, there is no fitting the equilibrium fitted, not fitted to the upper the through 365 nanometer emission energy. Then carbohydrates. I studied different carbohydrates, D-fructose, D-glucose, D-galactose, and this is for picric acid. This is selective person, and I got the this selective person for the 28.57 micromolar. but I varied to 0 to 170 1.42 micromolar, and I got the D glucose, so more sensitive towards the quantum dot, and also pityric acid. But in case of D glucose, it is a enhancing biosensor, it is a quenching biosensor. In this case, the process enhances, in this case, the process quenches. This is also selected for 315.5 nanometer. This is for the 441 nanometer. These are the standard class, well fitted. Conclusions: semiconductor lanthanum quantum are synthesized using sodium borohydride as a reducing agent. Crystal lattice compression are identified as a cubic hexagonal La2, hexagonal La4 for the element numbers. Third is the inertial or inner morphology of the quantum dots are shown by HRTM around 2 to 6 nanometer diameter range.
HRPM.
I-
That can SCM say 2 to 6 nanometer.
Yes, sir.
You cannot, it's in PM, you can actually do that, but your resistance is not there, what you have shown in the SCM.
Yes. That's why I use only
It's a
HRTM.
line.
Yeah.
Okay. Okay, you stop, no problem. Have you ever, since it is a biosensor of glucose, have you ever thought of working with the doctors here? Blood sample and glucose you have diabetic with you, just talk to them.
So I already talked, but I মানে ওরে ମୁଁ ତା ସହିତ ଠିକ ସେ କନେକ୍ସନ କରିପାରୁନି।
नहीं, अच्छा कोई it's so university. Some there, go to any diabetic person then in their R&D lab. Find out their blood glucose and other things, or pathology lab also. Suppose. Find out some workings with doctors.
Sir, madam এটা রিসেন্টলি করেছি তো সেটা
I am just telling.
আଜ୍ଞା
Good.
Slide number 2. The mixture at 0 degree Celsius. You have already taken aqueous solution of lanthanum. Okay. So at 0 degree Celsius, the solution is in which phase? Liquid phase or solid phase?
around 0 degree Celsius, not constantly 0 degree, because if you move stir the solution, if it is below the 0, then it is solidified. But around 10 to 0 degree. But I started the reaction at 8 degrees Celsius.
So you mentioned
You
0 degree.
mentioned that. Not zero, just put up to 6.
Like variation.
Another variation.
Variation.
At 0 degree Celsius, we know what are the phases.
No, if you move the solution is not freezing.
This is depression of freezing point. Solidity property, no, they are never solved. This will not freeze.
Okay.
And continuously stir. Solution is continuously stir.
No. Solidity property is there.
There is depression in freezing point. Depression in freezing point.
Just listen to me. He's taking it fundamental qualitative properties. You have water, you have the salt. So it will not freeze.
That's right. Depression of freezing point.
Depression of freezing.
Depression of freezing point.
You can do it at 0 degree also, it will not freeze.
Because you have salt.
So you are talking about the two excitation and you are getting two process.
Yeah.
So do you know absorption graph and excitation graph?
What's that?
No.
This is the excitation graph, black is the, and the red is the emission graph. But absorption is not fitted for the this sample, because I collected in a solid form. And if we take in the liquid UV visual, then it cannot show any peak.
We have visible diffuse reflectance spectroscopy is there. There you can actually do the solid samples.
So, ma'am, I also do the solid samples UV visual. From that, I got the band gaps, and I converted the band gaps to the.
I know the excited spectra and this one, but he is asking the absorption spectra.
But we don't have this kind of.
But do you have any idea what is the absorption spectra and excitation spectra? What is that?
Excitation spectrum is absorption spectrum is this energy. This wavelength energy is got absorbed, and the electron maybe it can be converted to covalent band, covalent bond or surface. Conduction band, conduction band or surface.
It's one step.
But in case of excitation, it only go to conduction band and then return to the valency bands. It cannot overcome the conduction band.
Okay, you go to your explain.
Question answer is approximate.
Everything is complicated.
Okay, thank you.
Question answer should be completed of 2 minutes. Read the question.
The next is trans.
Sir, 21.
Good afternoon to one and all present here. I am Psychology Doctor. I am doing my PhD under the guidance of Dr. Rachana and Dr. at Uttar University. My topic of oral presentation is enhanced absorption of methyl orange and methylene group on the polypyrrole tannic acid nanocomposite, its synthesis, its isotope study, kinetic study, and thermodynamic study. Before starting with the topic, I want to tell about the substance that impact color. That is dye. Dye found their significance even in our daily life necessities to even in regional identities. However, due to high demand, scientists introduced synthetic dyes to our environment, unaware of the fact that it was very toxic and very disadvantageous to the environment, like disruptive photosynthetic activities in plant, disruptive BOD, COD in drinking water quality, carcinogenic and teratogenic effect of human. In our lab, we are mainly focusing on adsorption because of its eco-friendliness, non-hazardous byproduct, simple process, high efficiency, and reusability. In this work, we are using a biodegradable polyphenol that is a natural-based polyphenol tannic acid, and we have introduced it to the polypyrrole to form the nanocomposite. My synthesis of the nanocomposite was done by in situ chemical oxidative method using an oxidant that is APS, ammonium persulfate. In the first step, the tannic acid was the polypyrrole group of the tannic acid get oxidized to O-quinone structure in the presence of APS, and during the process, H plus ion get released. The polypyrrole get polymerized in the presence of APS, and at the same time, it get protonated. The protonated polypyrrole form hydrogen bonding here, hydrogen bonding with the oxidized tannic acid group to form the nanocomposite. To check the synthesis and the morphology study, we have done various characterizations like XRD, FTIR, same, TAME, IDEX, and BET. In XRD, we found that the peak at 1634 is the characteristic peak of O-quinone structure, and the peak at 1719 indicate the carbonyl stretching group. The XRD spectra indicate that the compound was amorphous in nature. The cauliflower-like structure in same indicate it is a porous in nature, which is very suitable for adsorption. From TAME analysis, we conclude that it is a nanomaterial and the average size is around 53 nanometers. The presence of carbon, nitrogen, and oxygen was found in IDEX analysis. From BT, we conclude that the average area of the compound was 17.3 meters square per gram, and the total pore volume was 554 meter cc per gram. My nanocomposite absorb both cationic and anionic gas, that is methyl orange and methylene blue. The positive charge on the nitrogen helps in the interaction of the negatively charged amide, that is methyl orange, and the negatively charged O of the tannic acid group helps in the interaction of the positively charged MB dye. This helps in the absorption of both the dyes. To check the efficiency of the adsorption, we have compared it with the parent polymer, that is polypyrrole, and found it is very good adsorption. It is a very good adsorbent compared to polypyrrole for the adsorption of both the dyes. For simulated water analysis, we have collected many water samples from Kuakhai River, Kathojodi River, Chilika Lake, rainwater, and found our adsorbent was efficiency was remained intact irrespective of the sources. To optimize the condition, I have done various parameters like dosage, temperature, pH, initial dye concentration, and contact time. The optimized temperature of the adsorption was found to be 35 degrees Celsius for both the dye. The pH was around 6, and the doses of the adsorbent was 80 mg for both the dye adsorption. In initial dye adsorption and contact time experiment, we found that at 120 minutes the adsorption is in equilibrium. Our kinetic follows through the second order kinetic, and the corresponding equation is given below. The figure is figure 6 following the pseudo second order kinetics. My adsorption the adsorbent follows Langmuir adsorption isotherm, indicating it is a homogeneous and monolayer adsorption. From thermodynamic study, we confirm that it is a spontaneous process, that the del G is negative and del H value positive, indicating it is an endothermic process. The del S value positive, indicating it is increased in randomness. Lastly, I would like to conclude my adsorbent PQITA adsorb both MO and MB dye. The optimized pH is pH 6. The optimized temperature is 35 degree. The optimized dosage is 80 milligram. The maximum adsorption efficiency was 217.39 mg per gram for MB dye and 204.04 per mg per gram for MO dye. The kinetics follows with the second order kinetics. The isotherm is Langmuir isotherm. The del G value is negative, del S value is positive, and del H value is positive. The adsorbent can be recycled up to 5 cycles and it remains intact. Lastly, I would like to acknowledge my guide, Dr. Prajanaran Patra, Utkal University, all the members of OCS, my fellowship Urissa 2.0. This work has been recently published in ACS Langmuir. Thank you.
Here a comparison report that your dye and the reported dye is are better.
Yes, Mr. The comparison now with polypyrrole for both the dyes.
Whatever you are getting the value that the amount of dye is getting absorbed.
Yes, the maximum adsorption.
If somebody has done like the same thing, your this and composite, this is better.
Yes, ma'am, but I have not put it. Yes, but I have done that.
Just one suggestion I can give. We have textile dye in the West quarter. You work with this sample 3%. You talk to them, get the water, and do some work. And now you are doing in very small scale. Little bigger scale you do in you do, find it out. And work with the industry. Get some industrial and do it. Okay, thank you. Okay, then we go for mic picture. देखिए mic देखते हैं
बोलो
मेरे आगे
Sir, 23.
क्या खाया होगी कभी कभी खाई ना It is yours? Yes, yes. You can talk here. Slowly, slowly.
वहाँ पे जाओ इधर इधर खड़े ना मुझे लो ये साइड से चलो
Slowly बोलो हमारे आगे बढ़ो
First of all, this what is arsenic. It is one step. It is written water. That is arsenic is an alkaloid which is supposed to be regulated, and it is naturally in minerals which is found in everywhere in the environment. Among the organic arsenic and organic arsenic, it is not then and there are balanced arsenic among the arsenic 3 arsenic can be exposed contaminated rice, evaporation, drinking water, and etc. There are some arsenic toxicity which will toxicity and toxicity, moving, burning, and etc. Toxicity and cancer, nervous system disorders, and arsenic toxicity. More so among there are several medicines. Here we have chosen the products which because of this size that is below and I want to have gain attention to the properties and use of this is a nature and it is and there are which using so there are certain issues and challenges. Is this stability is user, stability of reputation of arsenic. So what on this limitation here was center surface consolidation and where it is the method that is we using this medicine surface consolidation and economic capability. So this is the medicine not using the lead extract and the nitrogen diffusion that is area that is using the resource and for the UV is in the range and using the recreation of UV visitors spectroscopy and we get and here 559 efficiently and emission. And this is the expedition emission. Here we see the emission decreases when we increase the expedition 294 to 400. This is the this is the clean analysis of end of product. We see the on from this products and the distribution spaces and this is the that's the end of and this is the space analysis of where we the figure B is the models that is 4 parameters and this is the correlation of the student and the then this was the validity in the range of 0 to 50 more and the reputation up to 0.9 and the limit detection is going to be 0.6 nanometer. There is the mechanism of differentiate And whereas the nitrogen was not 360. The excitation was the initial figure result, and when arsenic 3 is applied, then we see the effect. From this was the toxicity, almost 90%. And then we study the things under the same activity between operations supply and they will see the and notice the fluorescence will tell after the finishing this emission pressure. Then now yeah. But
Anyway, we have to get this. This is that. So you tell me that while you're talking that the arsenic 3 is more toxic than other oxidation is that. No, and you have to ask the chemistry student if you are telling that arsenic 3 is more toxic than arsenic 4 or arsenic 0, then why it is?
Okay, you don't know just all the time. You always better. It's just your subject. The organic chemistry from the beginning. I want to know why something is more toxic, what actually happens in the body fluid or something, what happens in which stage it goes, or what happens, and we should know.
Okay, we get it there.
Thank you so much. No problem. No, we could listen. Thank you. Okay. Shubha is fine.
Good afternoon to all the judges and all the participants. My name is Bhubaneswar and I am going to present my work, Selective Sensing of Tryptophan by Polyethylene Glycol Kept Silver Center, Raman B. Nanacomposite, under the supervision of Professor Pratibha Sir and Professor Sir Kumar Sir. These are the outline of my work. So, what is an amino acids? Basically, amino acids are the building blocks of protein, and proteins in turn constitutes all the muscle fiber and all the tissues in our body. Also, these amino acids, they are involved in some major metabolic process in our body, such as protein synthesis, melatonin synthesis, NAD and NADP processes. This tryptophan, it is an essential amino acid. That means it is not generated in our body, and we get it from the outside food sources, such as eggs, spirulina, etc. Higher level of tryptophan or lower level of tryptophan may indicate some underlying disease. That's why detection of tryptophan is necessary for in-human blood plasma is necessary. So we have taken silver nanocomposite using rhodamine B as the sensor. This nanocomposite is prepared by a very simple solution blending method using polyethylene glycol as a capping agent. After addition of rhodamine B, you can see under the UV light in the test tube B, it shows a distinct orange color. After addition of tryptophan, the color changes from orange to pink. This observation can also be analyzed in fluorescence spectrophotometer. Now, tryptophan has a very distinct functional group, that is an indole ring, while other amino acids do not have this indole ring. So our prediction is that the indole ring is interacting with the rhodamine B, and such color is observed because of that. And this mechanism is further confirmed by XPS analysis. Figure 1A represents the UV spectra of silver nanoparticles, the nanocomposite, and after addition of tryptophan. Here you can see that we also took histidine and cysteine, but there is no change in the UV spectra. But after addition of tryptophan, the peak is being shifted to around 275 nanometer. Also, we took the fluorescence spectra of the nanocomposite of before and after addition of tryptophan. In this peak, you can see that at 575 nanometer, the rhodamine B shows the peak here. But after addition of tryptophan, the peak is shifted around 365 nanometer. Now we took the XPS spectra of the nanocomposite after addition of tryptophan. It is a reported value. It is reported that the aromatic ring in the tryptophan, it shows the peak, the binding energy peak in the C1s spectra around 291.3 electron volt. But here, after addition of tryptophan, there is no such peak is observed around 290 or 291 electron volt. That means we can say that the indole ring is interacting with the rhodamine B. That's why the peak is not observed here, and rest of the peaks is accordingly that AZ3D 5/2 around 366 electron volt is due to the metallic silver, and this peak is due to the AGO bond. In the HRTM analysis, the figure A, B, and C, it represents the silver nanoparticles. As you can see, it remains pretty dispersed around the solution. But after addition of the tryptophan, it is forming colonies, and the crystallinity is also increasing. This is the fluorescence study. The figure A and figure B is the control study of the nanocomposite using different concentration of silver nanoparticles and different concentration of PEG. Figure C represents the fluorescence spectra of the nanocomposite with various concentrations of the tryptophan ranging from 0.01 micromolar solution to 1500 micromolar solution. And figure D represents the linear relationship between the concentration of the tryptophan and the fluorescence intensity. We also tested the nanocomposite with 16 other amino acids apart from the tryptophan. As you can see, only tryptophan is showing a distinct peak around 365 nanometer, while all the other amino acids are showing their peak around 575 nanometer. We also took human blood serum from 4 different individuals. As you can see, even in the presence of different bioactive molecules in the blood serum, the nanocomposite successfully detect tryptophan in the human blood serum. In conclusion, this nanocomposite is very easy to prepare as compared to other reported methods. Also, it has high selectivity towards tryptophan as compared to other amino acids. The detection technique is also very simple. Now, in the human blood serum, the optimal amount of tryptophan is somewhere around 30 micromolar to 80.1 micromolar solution. But our nanocomposite can detect up to a limit of 1.08 micromolar solution. Also, we successfully sense or detect tryptophan in the human blood plasma. Lastly, I like to thank OCS and the organizing committee of the OUTR for providing me the opportunity to present this work, and my supervisor, Professor Ranjan Mahapatra, and Professor on my lab. Thank you.
Slide number 18.
Yes.
You see that fluorescence spectra is increasing or decreasing? C. Let's see.
So the fluorescence spectra is decreasing, sir.
Decreasing.
Yes, sir.
So what is the concentration you are using?
The concentration is ranging from 0.01 micromolar to 1500, sir.
You see, it's coming bunch wise.
Yes, sir.
So why is it like that?
So
Not coming in a consistent way.
sir, this peak is at your 365 nanometer. Okay, so when you are increasing the concentration of the tryptophan, that means more tryptophan is interacting with the rhodamine B. And if you are adding more tryptophan, the peak will be accordingly like that.
It's fine, but if they're going down or it's coming down, you see, in one place it is many peaks. Then there is a gap, again there is many peaks, again it is coming like bunch wise.
Because sir, I didn't see, first we do 0.01, then 0.1, 1, 10, then directly 100 I have taken. There is no 20, 30. So there obviously there will be a big gap.
The blood sample you would have done.
Yes, sir. Yes, ma'am.
Where?
From Himsar, ma'am, we took the blood samples from different patients and we tested it in our lab. Yes, ma'am. We do collaborative work with the medicals.
Thank you.
Good afternoon, myself Dattatraya. I am going to present one of the anticoagulant drug, is alternative synthetic factor development. It is highly potent derivatives. I am synthesizing highly potent derivatives of that blood anticoagulant. So, our is background of anticoagulants, introduction of Epic-7 anticoagulant, synthesis, scope of reaction, spectrum generation, and then conclusion. So, anticoagulant is one of the medicines which help to prevent the blood. It is nothing but the blood thinner. So, they give on to the patient to prevent the blood clotting, to reduce the chances of strokes and heart attacks. So, the actual role of antibiotics is inhibit the specific pathway of the coagulation cascade, which in some case it directly inhibit the forming enzyme clotting cascade, and other is it reduces the thrombin formation. So some nowadays so many heterocyclic drugs are heterocyclic molecules are used in the medicinal chemistry. So these are some known marketed and anticoagulants: Betrix-7, Epic-7, Varafin, Rivaroxaban, and Edoxaban. So I worked on the well-known, highly marketed drugs, Epic-7. This is one of the second highest prescribed drugs in the worldwide market. So anticoagulant, Epic-7 anticoagulants is the drug which actually affects factor XA inhibitors, which prevent the formation of thrombin in the blood vessels. So that's why the thrombin is not forming, and it reacts with the serine enzyme, serine protease enzyme in the blood, and so blood thinning is happening. So the dose of this drug is 2.5 mg to 10 mg. 10 mg when any surgery is going on, then doctor prescribing 10 mg dose for 7 to 10 days. Later on, it dose comes to 5 mg, and 2.5 mg is for generally for heart disease or heart patients. So previously, reported there are several reported methods for this synthesis of this Epic-7 drugs. So many methods having metal used. But recently, 3-4 days back, US FDA restricted so many. US FDA put so many laws restriction for the drugs, like genotoxic impurities they don't want, like nitrosamine impurities they don't want. So many drugs companies are now reevaluated their synthesis. So Epic-7 is one of these drugs. So we also thought to reevaluate this synthesis of these drugs. Any drugs, if you want to resynthesize on the scale. Okay. So my aim is to removing the metals using this is also cost effective and easily available raw material. So accordingly, I tried to synthesize this with the thinking of the scale-up process. So I used this easily available material paranitro material with the PCl5 toluene. So I got this dichloro material compound number 2. This treated with morpholine in DMF, got material number 4 morpholine derivatives. with with treated with hydrogen iodide, reduction happening from nitro to NH2, and then I substituted this flychloropentanol chloride and got the compound number 7. With that, I did cyclization in acidic condition, work up by a basic condition to get this compound number 8. This compound then treated with compound number 11 to get the compound number 12, which on then the protection of that morpholin to get the 13. And from that 13 hydrolysis I did, got this compound number 14 acid. Then I made different derivatives of this acid with amine coupling. To prepare the intermediate 12 from 8 and 12, I tried the number of different type of reactions like using toluene solvent and different ways. But somewhere reaction is not completed, somewhere material isolation is not easy, somewhere reaction is not in. Finally, I found if I added the additive Ki in triethylamine and easy available solvent or easily MDC at low temperature, I got easy isolation as well as good yield. This number of new derivatives I prepared from this acid amine coupling. I used aliphatic 6-member ring, 3-member ring, some heterocyclic substituted ring also. Total number 19 new compound I prepared. So one of compound I took here for describing beta, NMR and C13. So their activity against this apixaban are in progress. So I communicated this work. This process is very cost-effective approach, easy generation of intermediate, satisfactory. Currently, I am taking each batch of this 50 kg batch actually. 50 kg. I prepared around now 200 kg material of this one. This is very big one. Myself only last 3 years, 50 kg. Developed in R&D, and when we took the validation test, then I have to go to the plant, and there I have to perform at least 4 batches. Then I come to the next one.
Since you are putting anticoagulant, what do you know about the ecospray?
Ecospray
is also an anticoagulant.
Generally, it is given.
I'm just asking.
Nowadays, heart patients generally keep this with them. It is blood thinner.
But it is becoming a problem for the heart patients now. Because blood hemorrhage goes on.
See, it forms the bruise. Bruise means small blood vessel breaks, and it is unstoppable blood. That's why nowadays there is also some drawback of this.
There's a problem it seems. A
Huh.
lot of people have been suffering.
It
If
forms
they take
bruise.
blood hemorrhage, if they don't take brain.
Yes. Blood,
There is no options. Can you just tell me if you have read the literature? If somebody doesn't take, suppose you are not doctor, but I'm just asking. Have you heard of? If somebody doesn't take ecospray, are they going to do such kind of anticoagulants?
That's what work is going on, because this even if with apexaban topic is forming if any cut forming now, the blood stopping is difficult. Most of anticoagulants, this is the main problem. This is the main problem. So
that will be not same problem will be there. Then why company will go for this? Why not ecospray?
see, when any doctor going for the surgery, then they have to give the antibiotic. So for heart patient also they have to give the antibiotic. But this drawback still not resolved. It is going on. Their potency is somewhere less, somewhere high. But still this problem is there.
So this you are working in a team?
Yeah, working in a team for the last 3 years. But personally, I in city, Sipla. Patented. Now we are going to file the DMS for this, because we have did some changes in process also, some yield also. So we are going to file this year. Thanks you.
Dr. Biswar.
Respected professors, my friends, we see you all in this exciting chemistry session. So in this presentation, I am going to present a diverse type of activity of this anaerobic benzimidazole, where we will discuss that how this simple reacting partner is giving two type of activities. One is giving stereoselective propionylation, or how it is giving 3+2 cyclation. As we all know that carbon-carbon bond-forming reaction is among the very crucial and fundamental transformation in synthetic chemistry. And if you look at the previous literature reports, we will find a series of methodologies that that may be either through traditional coupling reaction or transmetal catalyst cross coupling reaction. We can make this carbon-carbon bond. Particularly when we focus on this transmetal catalyst cross coupling reaction, the Sujitrost reaction is one of the very pivotal reaction where we can get allylated functionalities. In this type of reaction, what happens? The allyl acetates or allyl halides are used. And under this palladium catalysis, it will make this pi-allyl system so that a suitable nucleophile can attack to the electrophile to get this allylated compound. But as compared to this allyl acetate or allyl halides, allyl amines are less explored. The main reason behind this is the CN bond is quite stronger. If you want to explore the chemistry by taking this allyl amine, you have to use some activators like use of some Lewis acid or use of some protic solvent. Then how does these two activators act? This Lewis acid is actually coordinated with this lone pair of nitrogen, therefore it generates a partial positive charge, and hence you can the CN bond. Parallelly, when you are using protic solvent, it will make a hydrogen bonding interaction, and hence it weakens the CN bond. So once this allylamine gets activated, you can use different type of nucleophiles, and we can make it to the allylated species. So if you look at the chemistry of this allylamine, we can see that the nitrogen atom must have a lone pair, so that it can complex with the bonding acids, or it can make hydrogen bonding with the protic solvent. But what will happen if you are taking a system where you don't have lone pair of this nitrogen atom? For example, N-allyl benzimidazole. Here we know that since this is an aromatic moiety, the lone pair of this nitrogen atom is already utilized in the aromatization. So there is no lone pair at all. So now if I am using some activator like maybe protic solvent or boronic acid, then what will happen? The nitrogen atom present of this three position, it could be chelated, and it will generate a partial positive charge. But this partial positive charge can be moved to this N1 atom through the relay of the charge. This is called resonance. Now the question is whether this type of system could be able to deliver the alylation chemistry or not. And so this was our hypothesis, and it was quite surprising that when this allylamine, when this type of allylamine was subjected to the one of the heterocycles under this condition, we get quite unusual transformation, that is orthoselective orthofunctionalization as well as transselective propionylation. This result is quite distinct as compared to the previously reported literature, because there they were getting orthoallylation even though they are using allylamines. But in our methodology, what we observed that this is only propionylation. This result is quite distinct even as compared to the allyl acetates or allyl halides, because in those methodologies they were facing the problem with selectivity, because they are getting allylation along with the mixture of propionylation, and in this case they are getting mixture of trans as well as cis isomer. Therefore, in all these aspects, this method is quite beneficial. After getting this result, we optimized the reaction condition. We have screened more than 300 conditions, and with this optimized condition, a series of functional groups as well as series of heterocycles could be stereoselectively propionylated. We have performed a number of mechanistic experiments to understand the mechanism, and finally we have proposed this catalytic cycle. Here you can see that we have used the rhodium catalyst dimer, and it interacts with the additives to give this active rhodium intermediate. It undergoes reverse cyclometallation followed by alkene coordination, and removal of this benzimidazole give this type of allyl. Up to these, the mechanism is quite common compared to the previous report. But the interesting thing in this methodology is the isomerization. Here the terminal alkene is getting isomerized to the internal, and this is possible because of in situ formation of this rhodium iodide. This is also well characterized and well proved in our mechanism. So it will deliver the corresponding product. One more advantage in this product is even though you have one more ortho CH bond here, you have another possibility that this question could be also propylated. But the reaction is quite specific. We are not observing this dipropylated, rather it is stopping at monopropylated. So after getting this exciting result, then we presume that whether if we take normal aniline, whether orthopropylation could be possible, but this reaction was really harassing for us. Rather, it get a completely cyclase product, and we didn't observe any propylation here. Since this 2-methyl indole is very, very crucial skeleton in pharmaceuticals as well as drug molecule, and it is available in so many types of cancer medicine. We thought to explore the chemistry, and thereafter we optimized different conditions, again more than 250 conditions, and we got this condition. And with this optimized condition, a series of indoles were prepared. And in this project, we have also synthesized one of the drug molecule. After performing many control experiment, again we come back to the mechanism. Even though I am not even though I have mentioned this only one aroma, actually for each aroma we have performed separate control experiments. So this reaction also undergoes the same type of annihilation, but in this reaction here you have two pathways. Either it can go alkene isomerization, just like our previous methodology, or it can go intramolecular nucleophilic cyclization to give this type product. So in this methodology, isomerization is not happening, rather it is going intramolecular cyclization followed by aromatization to give this type of product. So after getting those two results, now I have switched my research area a little bit. That is, currently working this difunctionalization of this alkyne, particularly carbothioylation as well as carbofluorination of this alkyne. The alkyne may be symmetrical or may be unsymmetrical. Since these results are not up to the stage to be explored here, that's why I am just showing this. So in conclusion, we have discussed two distinct types of reactivity by using some traditionally unexplored imidazole and emojis under rhodium catalysis. Under one substrate system, it is giving only propylation, and in another case, we are getting cyclization. That's how this talk justifies that substrate selective switching reactions, where we are getting propylation or this cyclization. So at last, I would like to thank my financial supporting bodies, NIGER, Dependent on Energy, and as well as this SUR. And I thank the OCS to provide me the platform to share few of my things. Thank you. And now I will be very happy to interact with you if you have any doubt.
Last one. This carbofluorination of alkynes. Can you think of any industrial applications?
Yeah, definitely. Yes. Sir, industrial applications, as you know that, as compared to this fluorine atom, almost having the same atomic rate as that of hydrogen. And whenever it is normal CH bond, suppose I am talking about some simple heterocycles containing CH bond, that is showing some medicinal application. But when we are incorporating some fluorine atom there, so we are synthesizing some fluorinated heterocycles, this fluorine atoms actually plays a very, very vital role that it will alter the lipophilicity, it can penetrate through the membrane, therefore we can target the disease to further cure it.
Okay, that is one point. I have some interest that any fluorine additions we are doing in industry, we again, whatever catalyst we take or whatever we take, anything to adjust the fluorine, again we are putting it somewhere else.
Yes.
We are not able to disperse anywhere. It goes anyway. So can we do any such fluorination work? So can you stabilize?
So that you use those.
So that it can stay, it can be stable for so many years or something.
Okay.
Can you just think of with this?
Definitely.
Just think of
Yes. Definitely.
any type. Like suppose we have water fluorination is there. People are using fluorination work. Like they are using some maybe some ultrafiltration membranes. They are using the catalyst they are using. So they are taking it out. Like silica oils also they are doing this a good defluorination agent. So you can actually observe a lot of things on this silica oils also. After doing so, what you do? You put it in this. Even Nalco, when we do this aluminum melt, I think this is the last one. No, nothing finished. Okay, let us finish it. The Nalco also they do the pot aluminum they are making. That pot is actually the electrodes are having chlorine. So that they put it inside this and it goes to ground.
Yeah.
Can we think of utilizing some of the waste material which is having chlorine? Can we do something to do in this? Think of.
Definitely.
Thank you. Another one is there, Rakesh Kumar.
Who is your PhD then?
Actually, no, PC Ravi Kumar, but currently my PDF guide is Akhil Desai.
Okay.
Then I am working with
You see
students.
me? You see me here?
Yeah, yesterday is here.
No, not here. In your place. Okay. Rakesh Kumar.
Good evening. I'm Dr. Akashma Breda, a postdoctoral from Niger. I'm currently working under the Professor H.N. Ghosh, and I have completed my PhD from Professor Narayan Pradhan from ICS. Today I am going.
Your name was there. You are the same person?
Yes.
Oh, very good.
Today today's talk is on CSV VRP, BSc Architecture, Analytical Agriculture, and charge carrier dynamics. Before that, what is halide perovskite nanocristal? It is the most emerging material for the energy application because of easy synthesis, highly emitting material, and widely tunable. You can see we can tune just by changing the halide ion from blue to red region. That's why from 2015 to till that in 8-9 years, thousands lakhs of paper comes in halide perovskite material. But main problem when I entered the PhD, main problem for halide perovskite material was that most of the reported method was only cube shape, only cube shape, and because of the cube shape, only limited faces are there. That's why forming heterosexual with this limited facet is very difficult. So most of my main topic will be heterosexual of halide perovskite. But before that, I will present one work where we synthesize different faceted nanocrystal rather than cube shape. Then we use this multifaceted nanocrystal for the heterosexual formation. These are the application of perovskite nanocrystal. These are synthesis for multifaceted nanocrystal. Initially, we took phenacyl bromide, which has been alpha bromocripton, and along with lead salts and different ligand and copper-resin. When we degas it and inject oleolamine at high temperature at 220 degrees Celsius, initially it turned red color. With gradually annealing, this red color converted to yellow color. When we inject cesium to this red color solution, it gives cube shape nanocrystal. But when we inject cesium to the yellow color solution, initially it formed rhombic dodecahedron shape, that means 12 faceted nanocrystal, and with gradually annealing, this 12 faceted nanocrystal transformed to 26 faceted rhombic dodecahedron nanocrystal. These are the size dependent, temperature dependent size variation of 12 faceted and 26 faceted nanocrystal. Though these are the very large nanocrystal, the quantum efficiency is near unity. That's the most important property of this nanocrystal. And from the XRT analysis, we can see that these two 0 peaks from 12 faceted to 26 faceted additional 110 peak is gradually forming.
Go on. Last one is going on.
This synthesis protocol open the way to form the different heterostructure. As we have different facet, 12 faceted and 26 faceted nanocrystal. Can these new facet explore for the formation of heterostructure? Actually, we tried different method and to synthesize different which I am not presenting here. I am presenting here most actually after forming heterostructure with different metal. That metal is somehow easy, but with a covalent molecule. As this perovskite is a ionic in nature and chalcogenide is covalent nature, forming a ionic crystal and secondary and growth a secondary covalent crystal on ionic crystal is very much difficult. So we tried lead selenide to chalcogenide on CSV BRT nanocrystal at high temperature. When we inject selenium OD, we prepared selenium precursor solution to the preformed CSV BRT nanocrystal at 20 degree. The very good heterostructure form. It is for a 12 faceted nanocrystal. Again, for 26 faceted also, we will found a similar type of structure, but depending on the facet, the shape of this nanocrystal vary. We can see for 12, these are for 12 faceted nanocrystal. For 12 faceted nanocrystal, this tetrahedron shape PVC is connected, but for 26 faceted, a cuboid like structure. Students have PVC formed. These are the HRSDM image of the heterostructure. This part is PVC and this part is CSV3. Similarly, this is the same type of heterostructure but lying in different orientation. This white part is PVC and this part is CSV3. To confirm the epitaxial connection, we took the HRTM analysis. From HRTM analysis, we find that the epitaxial orientation is 110 of PBSC is epitaxially connected with 200 of CSV battery, 220 of PBSC and 400 of CSV battery. This is the another heterostructure where two PBSC connected to the same PBSC CSV nanocrystal, and these are the HRTM analysis where a 26 faceted CSV BRT connected with PVC nanocrystal. In both three cases, epitaxial orientation is same. That means PVC connected to the same facet, but depending on the size of the facet, the shape of this nanocrystal is changed. And these are the HRTM analysis. Again, for 12 faceted, we have focused on 12 faceted nanocrystal, mainly in same crystal but lying in different orientation. And the epitaxial connection almost same. That means to confirm the heterostructure formation, we took the XRT and from XRT we observed that orthonomic phase of CSV3 and cubic phase of PBS is present. And to confirm the heterostructure formation, we took the single molecule, single elemental mapping, where we can see these are layered parts, there are dominant part, here the dominant is missing, and these are selenium part. And from this mapping, we confirm that this is PBSC and along with CSPBR. Yeah. This is the atomic model showing the heterostructure formation in different orientation, same facet or different orientation, and this is showing the epitaxial connection of CSPBR3 with PBSC. The optical spectra, though absorption spectra for both CSPBR3 and heterostructure are almost same, but PL intensity quenching drastically for heterostructure. that's indicating some charge transfer process. Maybe because of the some charge transfer process, the PL intensity decreasing. From PL lifetime, we also observe that in initial time scale, the decay time is less for heterosexual. To confirm whether the charge transfer process, we took the ultrafast tangent absorption spectroscopy and for both pristine and heterosexual, and we observed that bleach intensity, this accidental bleach intensity for heterosexual is very less as compared to the CSV nanocrystal. Though the concentration for both the solution is same only. To confirm this, we take that kinetics as bleach position, and we observe that for and normalize it. This is the normal data. And for heterosexual, that growth as well as decay is faster as compared to normal CSV. For the CSV heterosexual is almost 2 picosecond, but in the case of CSV almost 30 picosecond. And these are the scheme of charge transfer process. It is type 1 heterosexual. The conclusion, actually we synthesize lead selenide, second we synthesize CSV nanocrystal, and secondary we got lead selenide on CSV nanocrystal. That is in the two different type of structure, and from ultrafast tangent absorption spectrum, you confirm that this the energy is transferred from or energy charge is transferred, not energy or charge is transferred from higher energy state of CSV to PDSC. This paper is published in JAS, and I acknowledge Professor Narayan Pradhan, PhD supervisor, and Professor Hirendranath Das, postdoctoral supervisor, and Larmans, Niger, and AIMS and the Association of OUTR for the performance of Award.
We have used any atomic mechanism for this documents?
Yes, we actually this image we have to
You said exactly.
in heart of SRST. This one.
No, the other one. This side.
Yes.
Did you use this? Did you use for this atomic mechanism spectroscopy or HRT?
No, for HRT. It is HRT. This image is to put in.
Even you could see the bromide.
Yes.
Yes.
You can see to from
That one.
That one.
I think the crystal size you are showing the what is it? Square size. Cuboid type. But that what is that?
This one.
Not this one. This one you see the bromide and atomic agency microscope.
Yes. No, this not this one. This one we see.
This one.
This one. Actually, we have to emphasize in this material.
What did you observe with the chloride, bromide, iodide?
Actually, the main problem for chloride, bromide, and these are for bromide.
Yes.
For iodide and chloride, main problem is because of the bromide in orthorhombic phase. That's why multifaceted possible. But for cubic chloride and iodide are in cubic phase. That's why other than 6-faceted, multifaceted is not much extra.
But your paper I saw that the potassium iodide is giving much better some.
No, CSVI3, yes, CSVI3 is reported. 6-faceted CSVI3 reported, and it is much efficient, and it is very good material for solar cell application. But multifaceted is nanocrystal for CSVI3 is not possible because of two reasons. First is cubic phase of CSVI3, and second reason is that this material, financial iodide, is not available. We have tried to convert CSVI to CSVI, but we will not succeed.
Thank you. Good. Sir, somebody was there, na?
Very neat. Concept of content.
Good evening. I am Makan Pradhan, present to you the brief understanding the absorption mechanism of chloride and chloride ions on magnesium oxide nanomaterials by the HSCB principle. These are my outline, introduction, experimental results, application, and conclusion. So, in introduction, magnesium oxide nanoparticles are widely studied for the unique property, that is physical and chemical property. The physical property is high surface area, alkaline in nature. So generally, we are synthesize the magnesium oxides in various methods, that is green method, soil gel method, autocombustion method, and there are various applications in biomedical application and ceramics and energy storage. So coming to the synthesis part, we have taken magnesium nitrate hexahydrate in solution A and solution B. So in solution A, we have taken magnesium nitrate hexahydrate plus 50 and distilled water, and in solution B, we take 0.1 ml of that is, glycerin and urea and citric acid plus 50 ml distilled. We are stirred it at 100 degrees Celsius at 2 hours. Then we have calcinated 500 degrees Celsius for 2 hours to synthesize the magnesium oxide nanoparticles with the combination of urea, glycerin and citric acids. This is the result of XRD, that is in the A part. Magnesium oxide urea is compared with the reference with, that is magnesium oxides, which are matched, and also characterized by FHM. The first two, the tower-like structure is for the magnesium oxide urea, magnesium oxide nanoparticles with urea, and the thickness is 10 to 20 nanometer, whereas in the magnesium oxide citric acid, the diameter is 60 to 80 nanometers. Coming to the third, that is index. This is the index of the three different characterization, and also this is the FTR study of the different. The FTR study is in OSP is around 3459 centimeter and 3435 centimeter. These are some applications, that the main application dye and chloride absorption studies. So the impact of adjuvant doses and types, it is shown that in the amount of absorption of the congolate is around 99%, whereas in the percentage of chloride, 96%, whereas in the amount of adjuvant is 99%. Next is the impact of interaction of adsorption and kinetic study. In this study, we have decided that the pseudo first order is better absorption than the second order for congolate dye and chloride ion, for magnesium oxide nanoparticles with glycerin. This is the coming to the next. Is the impact of adsorption of pH with coconut. Generally, we have taken the varying the pH from 3 to 9. It has seen that the pH is constant at 7, and it is decreased after 7.6 or 7.59. So this is known as 0 pH, that is isoelectric point also it is called as. So when the pH is less than 7.59, the surface is positively charged, so that the congolate, the negatively charged congolate dye and the chloride ions are more attracted, and the surface is more enhanced. But when the isoelectric point, that is 7.5, the pH is greater than 7.59, the surface is negatively charged and it enhances the surface. sorry, decrease the, reduce the surface.
Depends.
Yes.
Depends.
Yes. The last is we have to elucidate the mechanism, adjustment mechanism, the HSLP principle, that is Hearts of acid base principle. It has been seen that the aromatic, the del N and del E, the del E minus 13.3 electron volt when the Mg2 plus is interact with the nitrogen of conglomerate, its del E value is increased, and also in the aromatic region of the aromatic pi electron also minus 12, which is shows that there is better adjustment in magnesium oxide conglomerates. So in the conclusion part, magnesium is synthesized by autocombustion method, exhibited morphology dependent adsorption property, and glycine derived MgO out of others achieving high uptake capacity for conglomerate dye and chloride ions, glycerin mainly, and adsorption followed by pseudo secondary kinase and the glymer isotope, which I am not shown here, but I have explained the HSE principle, also adsorption doses. So these are my reference. The paper is published this year. Yes.
Isolated.
Okay.
You have studied the foundation. Why do you use glycerin?
Actually, we use 3 types of glycerin, urea, and citric acid.
Urea, you are going to make probably magnesium oxide. That is the one reactant. Magnesium salt, maybe you are using, probably, I don't know. I don't know. Okay. Urea is one of them. But we do use sometimes PEG, sometimes PBA, sometimes this. Why so?
Binding restricted the
binding
of also elimination of the particles and the
yes, that means dispersion.
Yeah.
Go to the this is the point. I just wanted to show you one of the students who talked about the dispersion. I told somebody. I said it to who? I don't remember PZC and pH. I don't know who talked to me. I don't know, one lady or somebody said pH you should mention when you work for sulfide. That I wanted to show you. This is the theta potential.
Yes, ma'am.
Okay. Or otherwise you can also see the electrophoretic mobility. Theta potential is nothing but a constant in the electrophoretic mobility. So the graph will also show like this. Electrophoretic mobility means you are giving a current and this will either disperse or agglomerate depending on this. So when you go to the isoelectric point, just imagine what he said that above pH less than 7 or whatever the pH is there, that is the PZC. This is a point of zero charge. In any type of free radical analysis, what we do, basic radical analysis when we do, suppose aluminium, always they say go to pH ammonium hydroxide and ammonium chloride and filter. Understand? They say common ion effect, that is the pH 7. pH 7, at pH 7, the PZC of alumina, that is the pH where we don't have any charge. So we filter. We don't get anything, we only get aluminum hydroxide, nothing else. There must be something, some materials will be there, but exactly if I see pH exactly 7, then we will get the aluminum hydroxide. If I filter just before that, I may get some other species with that. Understood? So like that, anywhere anybody says that this is the work and at this pH you filter, you collect, you do. So that is the pH we check. So pH is one of the more important things in any of the reactions. So when you go to this, the negatively charged things will be adject to that particular source. Maybe less than that, sorry,
less than
pH
7.5.
pH more than 12, just see. It is negative, zeta potential is negative. So if you have a And if you have an anion or cation or something like it will, you can make a composite. And if you have a negative ion, it will disperse. So you can get the glycerin, one of the dispersing agent, which will be disperse the material. It will not allow the things to be agglomerated. So you get magnetic nanoparticles is 5 means 5 nanometers. So if you think the PG, whatever suppose glycerin you are taking, or PG people are taking, any medical application, if you just suppose let us say 2% PBA or 3% PBA or 5% PBA, you will find the difference between the size of the valve. Okay, so that is the beautiful part of the colloidal suspension work. So anywhere you are taking magnesium oxide, suppose let us say you are taking chloride ion adjustment. So less than pH only it will happen.
Yes, yes.
So what I am telling, if the chloride ion are getting observed, have you studied that how much time it is getting absorbed? A research on is there.
Time
You have not studied,
not
but
studied.
it should be. If the magnesium oxide particle will be helping for the chloride absorption, can we make a mineralization of the waste chloride onto magnesium oxide and study it? Understood? If anywhere chloride ion is getting into the groundwater or something, any catalyst, can we use those things and mineralize on magnesium particles and keep it for years? Chloride will not come to the ground. That was okay, thank you. But this is one of the things, please study. Everybody, if anybody is in chemistry, when you study PZC, electrophoretic mobility, and the negatively charged this one, colloidal suspension may thousands, lakhs of papers are come. Everybody is working on this only place. If you suppose a nitric acid I am taking, let us say, I will be having NO2 or HNO or nitric acid, like that I will get, but at pH 1 I will get nitric acid. If I go pH, I will change it, I will not get HNO3. I will get something else. So for alumina, for magnesia, any oxide, there is a pH 0.06. If I take alumina, it will be 9. If I take a zirconia, I will be something else. So I will collect exactly in that. That is study. Okay, thank you. Chalo.
Correct your water formula. The water formula is now.
वाटर फॉर्मूला तुम्हारा क्या हुआ देखो देखो तो तुम वाटर हो गया तो फिर तुम्हारा सॉल्वेंट हो जाएगा
Chemistry student you should write
like sulfide very pH
Okay.
she should also know where the CO9S8 is coming. Because, no, what I'm telling, that a particular PHC of mixed sulfide, suppose they must be having a PHC condition. So exactly in that point, if you filter, if you collect, then you can get them. Otherwise, you will get some other also sulfide into one. So, thank you for your answer.
you are working in
Now the subject, there is a lot of problem here. Ministry there. That actually, I give all the certificates to them. Except That is, I have read your paper. You have a friend with same one case again.
Is in Bengaluru, Mumbai, Haryana, Goa, Madhya Pradesh.
They need the presence.
Yeah, sometimes they recruit fresh MSc, but see, API company is mostly not looking for fresher. CRO company is mostly looking for fresher, like Biocon, GVK. Even those also sometimes they recruit. But not that much like the.
Where are you actually? So you are from Sikra?
Yeah, I can.
Now from Sipla you have come.
Yeah. I'm working for Sipla.
ICT that
He is my co-worker. Ramabu sir is my co-worker.
ICT. Mumbai. Bhubaneswar.
So I will say you are
इसमें average से तो कैसे इसका तो इस बार
चार बार मछली करे